All right, so guys, welcome to this particular video. So just like I said, in today's video, we are going to be building a project. So it's going to be it's going to be highly led with demonstrations. And yeah, I do have very long sessions, 13 hours, 12 hours, and all of that. But in this video today, it might not really be up to that, right? We're just going to walk around project systems and who knows? So I expect that if you're watching this video, maybe in the future, participants in this particular lecture are going to be demonstrating some like of course they're going to be making some demonstrations, right? Particularly Abigail Obong. Maybe if you're watching in the future, by then she's the president of Nigeria, and just so you know that she was the one that was demonstrating, or maybe she's a minister or whatever. And again, Elizabeth, she's also a member of this cluster. Probably, if you're watching this video in the future, she's currently maybe the minister of artificial intelligence in Nigeria or maybe in USA or wherever place she has relocated to. And also we have Christabel Etim. She might be the Director General of Machine Learning. If I thought machine learning is existing by then. All right, okay, so please just put on your laptops and you could also join with your laptop real quick. And yeah, so what I'm going to be doing right now, like I said, I'm going to start by working on a project and I'm going to work on a project end to end. It's going to be strictly machine learning and I'm going to generate the data set myself. And then after generating the data set, I will do some classical machine learning, then make some predictions. I'm going to come up with the topic myself. We'll formulate the features ourselves, and then we'll now export the data set to a CSV file. So it's going to look like a data set you got online. So everything we're going to be doing in this video today is going to be entirely from scratch. And yeah, so at the end of my project, then I'm going to let the participants here to now talk about their machine learning journey, and then they would also do some practice. So, sure, as we progress in this session, I will be led by the direction, all right? But just for you to get that, what we're starting with now is me generating the data sets and getting started. So that's actually essentially what we're going to do in this video today for now. All right, so this is a machine learning session, so that means there are definitely a lot of people who are looking at strengthening themselves. So, like I said, we have VS Code. I'm just going to create a folder on my own. Maybe we'll just call this today's August 22, and so that's the folder. I just created that folder. I'm going to click on the folder, then I'm going to select the folder. That's how I did it. All right. All right. So this is actually what I'm going to be doing in this video today. Now, let me just kind of drag this down a bit. Now, I'm going to just close this interface here, close the welcome button. Now, this is actually where I'm going to be writing my code. All right. So the next thing I'm going to do now is to select, I'm going to click on this new file. Then I'll call it the name. Now, what am I going to call the file? I'm going to call it, maybe, I'm going to call it machine learning dot interactive Python notebook. That's a good name. But now remember, that has to be the extension, or you could do .py. Of course, it's definitely going to work. So I don't know if you guys are following up with me. Maybe you could also open your system and follow as I do. I'm good, but let's call it practice machine dot interactive Python. Now I use IPYNB, interactive Python notebook. That's the meaning of that extension. So I'm going to click on enter, and then that's it. Okay. So Abigail, are you with me there? Are you following? Christabel, are you following?
Yes, sir. I'm following.
All right, all right.
Yes, sir.
Okay, sure, sure. All right. So now the next thing you're going to do is if you are running on this particular interface, now let us click on detecting this kernel. So I'm just gonna, mine is still loading. So that's actually why I'm waiting. But immediately it's done loading now. I'm going to click on select environment. So it should give me option to choose any Python environment. So I'm going to choose Python 13.3, 3.13.3. Yeah, that's the environment where I'm going to be running my program right now. Okay, so it means that we are now starting. All right, so I'm going to shrink this phase. Just here, what I just did here is you can drag this area. So you can drag it, just keep your cursor here. You can drag it. So what this area here means is this is where you can create files, create a folder, whatever thing, any parts that you want to create, you can create those folder here. So that's actually what this place does, okay? So I'm just going to shrink it, all right? Now, now, if you don't have Jupyter Notebook installed, right? Because you guys are going to do, I'm going to be calling you out one by one. Now, if you don't have Jupyter Notebook installed, you could just create your own practice.py. This is also going to work. You can also write code here, right? You can write code here. Okay. All right. So, but we'll just stay within this place. All right. Let me see if I can change this to I like base of 13.5. Let me choose that. But you can choose anyone. You can choose any 3 points, whatever version. It's definitely going to work. All right, so this is actually what you need to understand. I could just delete this for now. We don't need it. Move to recycle bin. Okay, all right. So now, so I'm going to come to this particular place. Let me increase my screen. Okay, so it becomes more clearer. Just to, all right, okay, so now what I'm going to do right now is we're going to import our dependencies. I'm going to import our dependencies that we're going to be using to work on this project today. So what do I mean by dependency? We're going to be importing the libraries that we're going to be using. Because for you to write machine learning code, you need some library. So I'm going to take it slowly. Now, first of all, what project are we working on? That's the first thing. Now, let me say I want to work on, so I created a markdown now. I want to work on the diabetes. I think I'm kind of so tired about working on that. Let's say it could be a leprosy prediction model. Now, what do we mean by a leprosy prediction model? Now, let it not just be that I'm formulating something. All right. Now, if you kind of go online, let me just go online. Now, let's say I come to ChatGPT or maybe just kind of go online, right? And then you have something of maybe a hospital dashboard, right? Let me just call it prediction dashboard. Let me just kind of show you what I'm talking about. Mm, okay, maybe let's say I'm just look for any random image that's different. I'm gonna suit my illustration. Um, let's go to machine learning. And I'm just going to put login here. Okay, good, beautiful. Yes. Now let me just use this to show you an example now. All right. Now I'm sure you can see my screen right now. Now let's look at this now as a mental health prediction portal. Okay. Now forget about username, password, and all of this here. But let's just kind of picture something now in mind. Let's assume this is a prediction portal, right? And you want to predict mental health. Now, what are actually some of the things you're going to put here? Okay, you put your name, you put your password, your password, right? Of course, it logs you in. Then you have a portal that where you put your age. What's your age? What is maybe you ask some questions on depression. Maybe have you ever experienced something like this? Yes, no, no. Then at the end of the day, it gives you something of mental health. You have a mental health disorder or you don't have a mental health disorder. Now, that's actually the idea here, that you go into the laboratory, right? And let me just kind of push this back here. And let's say, we'll call this Leprosy Hospital Prediction Dashboard. And then this is just like the details that you're asked to enter. You enter your maybe what is the source size on your skin. Maybe this is your skin, and then you're kind of having some rashes, or maybe there has been some measurement. Maybe you enter what's the source size, what is your diabetes status, what is your, a lot of questions are being asked. And then at the end of the day, we'll now have the data dashboard predict you have mental health or you don't have you have leprosy or you don't have leprosy. Okay, if I could say that well. That's actually what we're going to be talking about right now in this particular model, machine learning. Now, you could have another thing in mind, but just so you understand that there isn't anything special that we are creating here. Because if you go online and you ask Google for someone, let me just say for someone that wants to diagnose if they have leprosy, what 6 features should they look out for? Okay. Now, what are you actually seeing here? These skin patches. So that means somebody for you to train a machine learning model that predicts whether somebody have leprosy or not, that machine must learn from a data set that collected information on skin patches, firm nodules, thickness of a large retina, was muscle weakness score, right? Ulcer, whatever, and eyebrow score, whatever thing. But essentially, what we're trying to say is that this machine learning deals with numeric data. So all of these things that you're seeing here has to be what? Measured. Now, guys, let's take, for example, you're the first person that predicts that wants to generate a model that can predict if somebody has HIV or not. Now, that is weird, right? What type of model could that be? As it stands now in the world, that model has to take, some kind of, I'm going to put it this way, it has to take some, maybe, of course, it has to take some data from maybe somebody's hematological, scores, maybe requires some kind of pharmaceutical insights. Maybe let's say, for example, what's your CD4 count? What is this and all of that? At the end of the day, it kind of makes some prediction, right? Now, but basically, what if you're trying to develop some artificial intelligence model that can predict at maybe let's say for example, you take a picture of somebody and the model is able to predict if the person has HIV or not. Now that might sound very weird and crazy, but basically what you need to understand is that that means there are now some facial features that will distinguish if somebody has maybe HIV and AIDS or not, or maybe tuberculosis and all of that. So that means there needs to be some extensive research that will bring people that have HIV and people that don't have HIV, check their facial qualities, do some rigorous skin diagnosis and research. That at the end of the day, if you're not the founding scientist that developed that model, it means that you've now got some massive insight from facial features. Now, but what am I saying that might sound somehow, but the point I'm trying to buttress here is that there are definitely some features that you need to be able to make some prediction. So that means in this video today, we're going to build entirely all those features from scratch, all right? But then having some kind of insight. So if you look at what we have here now, it's saying, okay, skin patches. So that means we're going to generate a data set for skin patches and assign some values to it. Then do the same thing for nodules, for thickness score, muscle weakness score, painless score, and loss of eyebrows. So let's say I ask it here, what if they are 8 features? Just list them in a sentence. And then what I actually want to do here now is I just want to kind of get some 8 features here, right, that we're going to use in making prediction for leprosy. So we'll build our own model from scratch. So what I'm going to do here now is I'm just going to kind of have something like this. And so just kind of feel free to think of any topic of your choice, anything you have in mind of using. So let me just do it this way. Okay, so that means we have our skin patches score and all of this, all right? So we now have an idea of what we are trying to generate now. Is a leprosy prediction model that's definitely going to be used. All right, so the next thing I'm going to do right here is I'm going to import the dependencies. So I'm going to say import the libraries for this model development, okay? All right, so you could follow with me. Now we're going to import NumPy as NP. We're going to import Pandas as PD. We're going to import Matplotlib .pyplot as PLT. And of course, we're going to import, because we're going to be saving the models, I'm going to import joblib. And I'm going to now let me just kind of give a comment. As usual, now this is for saving the model, all right? So this is for visualization, for handling the data frame, for mathematical computing and arithmetic related tasks. All right, so that's actually what that model is going to be used for. Now, from Scikit-Learn, now what is Scikit-Learn? Scikit-Learn, so it's kind of the module library that contains so many of the algorithms that we use in making prediction. Do you understand? So whenever we are talking about making prediction and all of that, there are algorithms where these things are actually contained. Now, it's not just algorithms, it also contains some functions that you can use to split a data set. It also contains some functions that you can use to pre-process data set, manipulate, a lot of things can be done using the Scikit-Learn library. So it's a very wide library, just so you know. Okay, so now when we say from sklearn dot, now that means there are so many methods inside of it, or let's say classes that we might want to maybe import, or dependencies that are actually situated just inside of the Scikit-Learn. So the path for splitting data sets, we'll get it from model selection, right? So when you go to the model selection class, or sorry, when you go to the folder for model selection, that's where you're definitely going to get it, right? So inside of it, we're going to import train test split. So that's actually the sub-module inside of it where you can get information that you can use to split any data set. Because anytime you're doing machine learning training, you're still having some part to train and some part to split. Okay. Now I'm going to also still inside of this place, that instead of me to come to another line and do from sklearn dot model selection import grid search CV, because we use this for hyperparameter tuning, which I'm going to talk about, right? I could just do it here, grid search CV. So I will reduce the number of lines of code, because only inside of model selection we have what to use for hyperparameters. In short, there are still other ones that are still inside of this particular, is maybe to fix threshold class, or maybe to perform some maybe stratified k-fold. If we want to split our data set for some, maybe if we want to split our data set and tune, maybe we want to split our data set, right? Because remember, the whole idea here is more of model selection and splitting data set. Then maybe get the maybe individual accuracy for each particular fold. Then we can get the stratified k-fold. Can also import the cross-val score. So what we use the cross-val score is just we use it, it's just like kind of the method that is going to only get one particular, is going to assess one particular metric per fold, compared to the cross validate. So you see that we can actually import a lot of things only from this particular model selection module. So we also have from sklearn dot preprocessing. So we're going to import standard scalar. So what do we use the standard scalar to do? We use the standard scalar to normalize the values, right? We use it to reduce the values, to scale them. Now think of it, if we want to do machine learning model training, we're not going to use, we're not just going to, let me put it this way. Whenever we want to do some machine learning training, right? And then we have the data set, age. Some of them have big numbers. Some other ones have small numbers. Some of them also have some kind of extraordinary values. In order to make the computer learn, we need to keep all those numbers together. So that means standard scalar is a class that is built to help us do this, because inside of that class, it contains some methods like maybe, because if you want to scale it, you might do some transform, right? You need to transform those values, reduce them. More when we start practicalizing it, it's going to make a lot of sense. So, but inside of this, we have the min max scalar, we have the min max scalar. So the min max scalar also does similar thing like the standard scalar, but whenever you're using the standard scalar, you're more conscious of the standard deviation. So that's also drawing inference on how you're scaling it. But whereas this is just going to shrink from 0 to 1. Don't worry, the explanation here, when I scale, maybe like I said, we'll generate the data sets ourselves, and then of course we'll definitely scale it ourselves. I'm not going to work with the min max scalar. I'm going to work with standard scalar. So we also will go to the Scikit-Learn again, and then we can go to the pipeline to get pipeline, but I'm going to just kind of keep this simple. Unless you guys want me to do some kind of pipeline, probably if I run another example. But we could also go to the compose and import column transformers, column transformer. So column transformer is just like, think of it like a substitute of when we'll be doing some one-hot encoding and there's some, instead of us having to do some things manually, we can use column transformers to do that. I'll show you what I mean by that, but in this video, I'm going to keep it simple. We'll do the manual one, manual end-to-end project. Then another thing we might need is we might also go to Scikit-Learn. And then, of course, if I kind of hover around here, so these are several classes, right, where we can do a lot of stuff. Now, maybe we could just go to the model that we want to use. So let's use the neighbors, and I'm going to use the k-nearest neighbors classifier. You can also use the k-neighbors regressor, but for now, I'm just using the k-nearest neighbors classifier. So this is what we're going to be using. So this is our algorithm. The algorithm we're going to be using. This is for feature engineering and pre-processing. So this is actually what we use for all of this part here. And this is actually the algorithm we're going to be working with. Now, how do we now check if our model is performing well? So we'll go to the sklearn.metrics, and then that's where we're going to import so many things, right? You could just wrap this inside of a tuple, and then you could import accuracy score. It works. Let me just unwrap it, because some of you might be asking why I didn't wrap this, but if you still wrap this in a bracket, it's also allowed. It's allowed. So I'm going to import accuracy score. I'm going to import cross-vals. No, I'm going to import RC AUC score, RC curve. I'm going to import precision score. Then I'm going to import recall. I'm going to import confusion matrix. I'm going to import classification report. And I think that's actually that for now. All right. So let me just kind of keep it simple. So these are actually some dependencies for evaluating our model performance. So I'm going to run that, and everything, of course, definitely works. So remember, you must run it. You must run it. Okay, you must still run that, and you still have to run it so that everything works. Now, immediately I'm done with that. Now, let's create our data set. Now, that's what I'm going to do here. Create our data set. All right. So normally what I would have done now, guys, is maybe we'll just go to data sets online and get an Excel sheet that somebody has used. But we're not going to be doing that in this video today. We're going to be creating our own data set from scratch. So I think I need to see this, right? So just to know what we're going to be getting, and I'm just going to copy this and just kind of copy that. Go down here, just paste it so that okay. And what I'm going to do now is, so I'm going to do now, what is this now? Now I could just create a function. I could create a function here. And I'm going to call this function create data sets, okay? Now, you already know what a function is, okay? Because if you want me to do it outside of the function, of course, that still works. So I'm just going to say seed is equals to maybe 78, and then n is equals to 1. How many, what's the number of people we want to have on the data set? Maybe let me make it 1, 6, and then that's it. So that's actually what I created inside of this function. Now what I'm going to do now is, still inside of this function, I'm going to call, say, data set is going to be an empty list. All right. Yeah, maybe I'm just going to call it data, an empty list. And then now let us start creating the features. So I remember we called it features. All right. So this is actually what I'm going to be doing. Now, so what I'm going to do now is I'm going to wrap it in a for loop. So that's one style. Now, but maybe you guys might want me to keep it out of a function so that it's something that is easy to understand. And I could still keep it out of a function and still not use a for loop, so that I will be able to consume all the parameters that are inside of the each of it. So let me just kind of keep it out of a function. So I'm going to say data is equals to an empty list. And then now I'm going to say, now what I want to do, now the first thing is going to be skin patches, right? So I'm just kind of creating that, and just to reduce the lightning on my face. All right, so that's it. So what I'm going to skin patches now is going to be NP. Now remember, NP is the NumPy that we did import initially. So NP, now think of anything. You can think of diabetes, whatever. Then maybe your first one could be age. And I'm going to let me make it age. So the first one is going to be age, NP dot random dot randint. Remember, we did that initially, which is the method for generating a synthetic data. Then here is going to be, it's going to take in the first parameter. Low is going to be 0 or 1. That's the lowest age is 1. And for leprosy, let's just kind of bring it upside to 8. And then the high, this is actually what we call we call these things the function parameters, right? Parameter names. So that's what all these things are. These are the parameter names. So this is the parameter here. And then the highest age is going to be 90. So it's not going to count 90, it's going to stop at 89. And then the size is going to be 1,600 people. That's what I need. All right. Now that's for the age in my data set. So whenever I'm going to create this Excel sheet, it's going to give me random ages within this particular stuff. So I'm going to actually, for skin patches might seem maybe like more like skin patches, we could measure it from as an integer, right? Remember, we have data type as an integer, as type int. So random, so it's random dot randint, and then it's going to be lowest is going to be 1, or let's put 0, and then the highest is going to be 10, and then the size is going to be 1,600. Okay, I'm just going to delete this function. Now, what else do we need? We need skin noodles or lumps. Okay, so we got it skin lumps. But remember, just call it lumps. So lumps is going to be, now lumps, somebody that went to a healthcare facility and they are measuring the lumps. Probably, let's say they are measuring it in floats. Floats, you know what we mean by floats? So floats is something like maybe 10.2, 56.3, and all of that, right? Right, so let's say the lumps, random. Now, we're not going to use random now because it's not an integer, it's a float. So let's use uniform and random.uniform, and then it's going to be, it takes in that same parameter, and then that's the param name. And then maybe the lowest is going to be 1.0, and then the high is going to be maybe 32.7. We're just, and the size is going to be 1,600. Okay. And then now that what else are we looking at? Maybe thickness of the nerves, nerve thickness is going to be np.random.poison. We could use that just to get some numbers that are scattered within a particular range, but I'm not going to do that. I'm going to use random, and then we're going to call it, it's going to take low, as maybe the lowest could be 8, and then high could be maybe 60. Maybe let's just put it at 50 or something, right? And size of 1.6. All right, guys. So another thing, let's say residence, where the person lives. You got it from the questionnaire, np.random.choice. Okay, and now remember this is going to take in a list inside of it, and then that's going to be rural. And let's say some people said urban, right? And then somebody now wrote village inside the questionnaire, in short, with capital letter. Are you following? Are you following? Now, because we are forming the questionnaire, and then inside of it, somebody now filled in something like asterisk or something. I'm just gonna put something like an asterisk. Somebody just put something like this. And then still inside of it, somebody now filled something like what other mistake can people make? Maybe the person filled in something like watch. This is village in lowercase now, and then had an asterisk. Some people will do this. Are you seeing it now? So this one has normal village, uppercase. This one has smaller case. And then let's say somebody now puts in something like city. Now, what we are supposed to have here using our domain knowledge is just two things. It's either you're in the urban or you're in the rural. That's it. Urban or rural. But then we are still going to use our domain knowledge because it happens in real world. I want to make the data set so dirty. Now let's say another person now has because staying in the village can be a contributor, because of knowledge and all of that. I don't really want to kind of make this so boring. Let's kind of say loss of eyebrow. Let's see eyebrow eyebrow loss is maybe something like np.random.rounding. And let's kind of say that maybe I could have just want to show you guys how normalized values are, but maybe I'm going to do that for ulcer, right? Let's kind of make a choice. Let's say this will be filled with choice. And then they said something like yes. And we said no. And some people said why. And then some people said nope. And that's it. Okay, yes or no. And then some people said none. Okay, so let's have it that way. And then some people also use the capital letter yes inside it. Okay, I think I didn't pass in something here. I would have passed in size as 1.6, and also it's going to take in size as 1.6. And is there another thing you have in mind? Maybe we could say nasal congestion. I just want to use something different. Nasal congestion, and then of course np.random dot. Maybe this time I could say dot normal, and Now, let me just kind of show you guys something now, right? If you kind of put 4 here, let me just show you what this looks like. Let me just kind of create a function here and call this random. Let me just call this stuff, okay? And then let me just kind of print stuff. So you see what it's going to print. Print stuff. Now, basically, it's going to give you this now. But if you kind of try to pass size of 10, let's see. Now, it gives you 10 values that are normalized. That is what the normal method does. So it kind of gives you some numbers that actually normalize, but they're actually within this, they're clustered around 4, more like as the more like I would like more like the standard deviation, right? They're just values are actually clustered around 4. And if we just kind of change this to choice in place of rounding because the string is a string. Yes, 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 exactly. So we use the choice. The reason why I use the choice is because it is a what? String value, okay? So each time you have a string, you use choice, right? If you have a float, you use uniform. You could use uniform, you could use normal, you could use random, because we also have, let's say, for example, pin score. Remember, now I'm out of my store. So now np dot random dot random. I'm just going to print this random stuff and I kind of print pin score. Now it's just going to kind of generate a random number for me. I don't really need to pass. Okay, I could just pass 1. I could just pass 3. I could just pass 4. It's going to give me 4 normalized values, right? So it kind of gives you some normalized values. Now you can't pass another value here. It's going to throw an error. All right, so that's what it's going to do. It's going to throw an error. That's all of this waste of time now. It's going to lead to an error. All right, so you can only pass in one value, which is the size. So the only thing the random is going to give you is going to give you normalized value. I think I do have a video here where I explained all the NumPy magic methods. For short, that's like a 20 minutes video. No, I think it's 1 hour. It's not up to 1 hour, but it's a very short video where I explained all of these, all the NumPy methods, how to use it in generating value. So you could just check out that video, right, where I've actually explained it. We also have the random.poison. We have the np.random.poison, that it just generates some kind of, scores. So here it's going to give me, let's say, can I say it? It will give me some numbers that are actually clustered within that range, but they must be integers. Here, the question here is that they must be what? Integers. But if you are using the normal, right, it's going to give you, it's going to just give you some kind of, some values that are clustered around this particular number here as per the range. So so if you put a size at 10, it's going to give you 10 numbers, right? That are the float values. But then the standard deviation here is they are just kind of clustered around 10. That is what it's going to give you. Now, the difference between normal, I'll repeat myself again. The difference between normal and random is that must give you numbers that are within the range of 0 to 1. Only that normalized values that are within the range of 0 to 1. So there is no need of you even putting something like maybe anything that it only takes, the only argument it takes in is the size of numbers that are between this range of 0 to 1. So if we're creating for generating a synthetic data set and we pass random there, it's giving us only values that are between the range of 0 to 1, normalized values. If I pass 19 here, it's just going to give me 19 numbers that are between the range of 0 to 1. Let me just kind of mention that here. numbers between the range of what? 0 to 1. Please pay attention because you're going to be creating this right away now with me. This is what we're going to be doing. You're going to come up with your own. So it's the question now is, what am I going to do now that might require me to do this? Now, if I kind of come here, guys, watch. If I kind of come here now, because this is random dot random. This is random dot random. And I say something like nasal, let's say pain score, and I put random dot random. What do I need to pass in here? Only one thing, 1,000. It takes in argument of size, 1,000. So in short, I don't even need to pass this size here because it might throw an error. The only thing that can be passed here is what? Random numbers that are what? Showing pain score. And that pain score is actually between the range of 0 to 1. Okay? Now that's it. Now, but the difference between that and normal is that when you put normal, it's going to give you numbers that are within, that are clustered around, in short, they are kind of normalized values that are clustered around 10 as their standard deviation. Do you understand? So that's kind of what it is. So if I have here now as 80, watch, 80 now, watch. Now you see that 80 here is the mean value. It's more like kind of the mean value. So that's just like that's the standard deviation now of those particular values here. Because this could be something like log. So this is actually the path. This is actually the what would I say? This is the path. This is the default parameter name. That's like kind of the parameter name that it takes. So whenever I say log, you say that 8 is more like the central point, is the standard deviation of those numbers. All right. So 8 is the standard deviation. So it's more like, let's say I'm trying to generate a data set. Now, what will require me to do this now? Let's say, and again, it has to be float. Remember, it has to be what? Float. That's float number. So let's say I'm generating a data set now. What can I think of now? Maybe let's say, for example, muscle weakness, or no. Let me say, for example, temperature. So now when I say np.random.normal, now my common sense, what I'm going to have here now is what? The log, the standard deviation now is going to be something like what? That's the central point. Now, something like maybe 36.6. Okay, that's the standard temperature. Then that means actually the size, I have to actually pass that part parameter, and it's going to be 1.6. So what I mean now, if I kind of take this here, this temperature here, watch, and I go down, because I'm generating a data set, I cannot print. I'm just going to reduce this because this is too much. Let me reduce it to something like 614. Print temperature. You see, it's going to give me people's temperature, and it's reasonable because I'm generating a data set. So it means that some people might be 37. It's not everybody that is going to be 36. Some people might be 34. Some people might be having 35. Some might be this and all of that. That is just the idea. So this is what we use NumPy to do. So some of those arithmetic tasks, we do it with what? NumPy. All right? So this is actually very, very, very easy and simple to create your own data set. All right, so guys, you now know the difference between random.normal, because this is normal. So whenever you have normal, random.normal, it means that you need to tell us, okay, what is the value, central point of that value? And then you also must pass the size. Because if I had just wrapped this in the for loop and then do it, you might not really understand what I'm doing. It might just be, confusing. But now that AI is available, it means that you must understand your code very well. In short, I've never seen a time where you need to understand how to write code than now. Because since now everybody can generate code, this is a point whereby you need to understand, when you're reading your code line by line, you're understanding what this one means and what this other one means. So guys, the last one I'm going to just say now is we have np.random.poison, right? Now here, if I kind of pass in 56, now let me just pass in 56 here, and then I have size at, maybe let me just kind of reduce this to 10. Now watch what it's going to do. Okay, give me an array, but let me just kind of call this fruit score, okay? And then just print that. Print fruit score, okay? All right, now what do you understand here? Now, this and normal is closely related. Now, the difference here now is that this is the lock, more like that lock that we use, right? Or maybe we could call this standard, whatever thing. But if you hover around this particular place here, it's going to, if you hover your cursor here, I don't know why that is not showing me now. But usually when you hover your cursor around, it's going to pop up, something is going to pop up. And then of course, it's going to show you what this particular NumPy method is all about. But looking at this now, you see that the same similar thing we had for normal, we are having it with this poison. So poison is that it gives you some kind of distribution around that particular number. So this is more like think of it as the standard deviation, or more like numbers that are clustered around it. So that's why you have 49, 38, 64 and all of that. If I cannot increase this more, let me just increase it to 500. You see that this is the same numbers that are clustered around it, right? You have 535 and all of that. So more like it's expected that these are the numbers that are clustered around. You can't be having 2 here because it's very far away from it. But the difference here now is that this is for what? Integers. It gives you what? Integers. But for normal is going to give you what? Floats. So let's kind of use poison here. So let's say we want to get, what else? Muscle weakness or paralysis is also going to be in our data set. So we say muscle weakness score. Sure, let's call it muscle score. Muscle score. Now, np.random.poison, and then we'll pass in, maybe let's say, for example, let it be from 1 to 10, right? Now, let's say muscle score is expected that your muscle score should be around maybe 45. So if when we pass 45 and then size at 1.6, right? So that means it's going to just give us numbers clustered around there. Now somebody might ask them, but why don't I use randint? Now the reason here is that you only use randint when you want integers that are within a range, right? If you want integers that are within a range, I need to explain this very well for you guys to understand. Let's assume that I use the age now, and I use poison for age, and I place it at 56. What will happen? That means we're not going to have anybody that is aged 8 years old there, because it's just going to give us age of people that are clustered around 56. So it means that, okay, we want a range. That means we will need to use the randint. So let it give us age from so and so to so and so. But now let's say in a situation whereby we don't want something of, we don't want you giving us something from 25 to 100 as muscle score, because it's going to be so, like the interquartile range is going to be so stretched. We expect that by our senses, that for people to have their temperature should be within the range of 37. It should just be clustered around 37.6. So in that case, we use what we call what? If it's for integers, we use randint. Sorry, we use poison. But if it's not for integers, we use what? Normal. But if it is for range, where we don't want it to be integers, but we want it to be from a particular range, let's say from maybe let's say scores in class. Okay, some people are going to score 0. Some people are going to score 100, 100.0, 0, 34.5, 96.6, 22.5. Instead of using random, because it's decimals, we use uniform. So uniform is the assist, is just, I see now, I see what I'm seeing now. I see that that thing is showing. So this is what I was talking about. When you hover around it, it shows you the parameters inside of it, and you can just read the documentation. So these are what we call documentation. So if you go into this thing in details, you can read the documentation of the method. So if we have decimals that are within a range, we use uniform. We will clearly state where the lowest will be and clearly tell them where the highest should be. If they are not decimals and they are range, we'll use random. We'll clearly state where the lowest is going to be and where the highest is going to be. If they are not numbers at all, we'll use choice. So what are choice? Choice are not like qualitative numbers, maybe educational score. Let me just add it here in our data set. Educational score. So let's say mp.random.choice. Now, we're not just going, someone might ask, okay, can I just start passing in the values here? No, we need to pass it inside of a list. Now, instead of that list, we'll now have something like maybe, instead of the list, we can have maybe what is primary, right? Sorry. Remember, you follow the rules. Secondary, tertiary, none. Sorry, I think okay, none is not a keyword, so you don't use none. No, no one. Let me just say no one. You don't use none. None is a reserved queue. Why am I having? Kind of looks like something random.choice, and then you take a list. But I'm just going to remove this. Okay, good. Okay, I think I mistakenly made. Okay, so I said no one. All right. So I can't really use none here. Okay, could still use none anyway. Just wrap it inside of a quote. And then what else? What else? What else can we add? Maybe somebody will now write something like maybe somebody now filled in asterisk there, dash. It's possible. And maybe somebody now filled in maybe let's say maybe that's it. Somebody just is not filling anything. Let's just leave it this way. So somebody can fill in dash there because they don't want to fill it. So it's going to happen, right? It's something that will happen. Then size of 1/6. Okay. All right. So I'm going to run the code in a plain manner so that we're not going to, it's something that's going to be really, really very easy to understand. All right, so that's actually that. I've kind of explained several NumPy magic methods. You can just look up. I do have a full video on all of the methods on my channel. I think that's like 20 minutes. Maybe link is going to be added in the description of this video. Now, the next thing we're going to do right now is, since we've actually created this data set now, what else is missing? Now, remember, if you're getting a data set online, it's also going to show the last column of what the person was diagnosed as, right? So that could be something as maybe result. Let's just call it result. Some people can call it result, or some people can call it label, or some people can call it diagnosis, or some people can call it whatever thing. Now, this is actually a classification-based machine learning, right? More of we are classifying, we are doing classification in the sense that we are trying to classify if this person has leprosy or not. Now, but I'm going to use a logic to build our label. Look at what I mean by that now. So I'm going to say, let's just call it result. right? Now, result is going to be, what is going to be in the result session? Now, if I kind of take you back, let me take you back to one of my explanations I used to make. Let me just kind of open something here. Let's go to maybe Microsoft Whitehead. Just feel free to use what you want to use. And I'm just gonna sign in and just I'm just gonna show you something, guys, in a jiffy. And okay, just got that. You see, we had numerous tons of lectures. All right, so I'm just gonna kind of close this right here, guys. I'm just gonna say this is August 22. I'm just gonna now let's say you have something like this. And then this is a data set, right? Okay. And then you have something like that. What's wrong with me? And now, let's say this part is your label. Okay. And then you have all the parameters here, 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 here. Now, usually what you could have here now is you can have something like positive, negative, positive, negative, right? That's one. Now, in another data set, you could have something like this. And then in your last column, you could have something like maybe good, bad, good, bad. And then we can now decide to convert it into 1, 0, 1, 0. Or we say that bad is going to take 1, good is going to take 0, and good is going to take 0 here, and it's going to take 1. All right. So this is actually the idea here. When you go to the hospital, and then maybe let's say you collect results on people's maybe HIV status. Now, at the very last end of that particular of that data set, you're going to have something like it's reactive, non-reactive, and reactive. Now, you're not going to have any other thing apart from this. This is just what it's going to be. But in any case, maybe you have something like maybe inconclusive. We're going to assume it. We can't use it to train our model. Anything that's inconclusive, we'll drop it. So we only have reactive, non-reactive. So what reactive means is positive, non-reactive is negative. So we can now call it 0 for, sorry, we could say for reactive, let it be 1. For non-reactive is 0. For reactive is going to be 1. And all of that. That is the point. But what I'm going to do here is I'm going to use what we call a ternary operator, right? I'm going to use a ternary operator to write the logic for this, right? So what do I mean by a ternary operator? It's just going to be, I'm going to write the logic in one line. So I'm going to say return positive, okay? If now what is that if here now is we're going to write our condition, right? So this is actually one style. So if you find this very difficult, I can decide to use the normal way. But but I just want to use this approach. Now let's be positive in that data set. If what is going to be the condition? Now let's ask ourselves. So what should make somebody leprous? For example, let's say the person is having a lumps that is greater than let's say the person's lumps is greater than 15.0. Okay, so what again will make somebody qualified to have leprosy? Maybe the person is having fever, right? And then let's say, for example, their temperature, temp is greater than, uh, let's say the temperature is greater than 36.6, high temperature, body dey hot. Now, what else? Now, I could use this maybe to say if it's equal to yes, but the reason why I wouldn't use this, I don't want it to get confused in the logic, because we need to convert these things, some of them to yes or no. I need to properly handle these data sets here to convert none to no, put all of them together. Everything that is y and yes, encode them into yes, so that we don't get confused. Because here, if I'm trying to write this logic here, that means I'm going to make sure I use all the particular terms here, which is still fine. Of course, I could still do that. If eyebrow loss is equal to yes, but let's not just make judgment here, because there are some people that might not have eyebrow, and then of course they are negative. So let's just not limit it here. The skin patches is, if their skin patches is greater than maybe 6, okay? So that's actually enough condition. Let's not use age to make judgment. And let's not just use educational score, because if we just limit it to only tertiary and tertiary, that means we're now saying that primary people, or maybe if we limit the education only to people that are primary, then that means we're now saying that people that are tertiary will not have the infection. So that means there is no need here. So, but let's kind of limit our logic to these people. Yeah, so we're making our judgment here based on temperature, and so our judgment here is based on temperature, lumps, and skin patches. Okay, so now watch how I'm going to write the logic now. So positive if for temp, okay. Now, there is only one issue that we might have here, which is how to figure out the size. And but let's just write the logic. So if temperature is greater than 36.6, because this is not inside of a loop, and we use this particular, you know what we call this now? These are some kind of operators which we've explained. You got to show the couple of full course there. We did explain that. And then also, because this is actually a very strict condition here. And then if the lumps is greater than or equal to, let's just gonna use equal to this comparison operator, and here is greater than or equal to 15.0, and what else? And skin patches is greater than or equal to 6. Okay, else negative. Okay, so this is what we call a ternary operator. So in that case now, what will happen here now is we need to kind of say for I in range of 1, 6, and then so this is very important. Now, the reason why we did this, it's just so that we can have, this is not inside of a loop. We don't have something like maybe coming here now to say maybe size is equals to this. No, we can't do that. So just kind of better for us to do that this way, all right? And then if I want to kind of change my data set, because of this assignment here, I could just say something like size is equals to 1, 6. Now what I'm going to do now is I'm not going to replace all of this with that variable of size, and I'm going to replace it with size. I think there's a shortcut to press so that automatically it will highlight everything. But let me just do it carefully so that you guys understand. Remember, this is a variable that is holding that 1600. Okay? Size, and anytime we use uppercase, it's only usually when we don't want to change it. If it's in JavaScript, we don't even need to do it. We just say const that, and then it's not going to change. Size. All right. So we run this. What's the issue? It says if so, let's kind of wrap this in. Let's just wrap this inside of this. If temperature is greater than this, and just want to know what is wrong, trivial of any message. One ambiguous, ambiguous. Positive if temperature is in skin patches, else negative. It's greater than, okay, let's okay, so let's kind of reduce to temperature and lump. But any, that's not all. I don't want to use that. If positive, if temperature is greater than, and let's just take on temperature and see. So much to go through now. What is the okay? See what we're gonna do now. Let's say result. Wait, let me just kind of comment that out. I'm gonna come back to that. So what we could do here, we could say result is going to be np.random.randint, and then let's kind of just give it some, let's take choice, and then of course we could put it in a list. We could say positive, and then we're gonna say negative, okay, and then we're gonna size is gonna be equals to size. Okay, that works now. And what's it? So I think that's actually that. Let's just kind of leave this 10 array and just have some random. So no, let me just leave that there. Okay, so guys, the next thing we're going to do now is since we've got this, now what we're going to do is remember I'm kind of doing all of this outside of this, and I don't really think there might be so much need for this empty list here, but we're going to create a dictionary. We'll call it our data set. And now this is what is going to take the headings, there's the column names of our data. Now I'm going to mess up the names, some of the names, just for it to look like a real world data. When you get the data set online, there kind of usually some, how would I put it? Like there are usually some wrong names, the way the names is being spelled, some are uppercase, some are lowercase. So I'm just going to create that scenario. And what I'm going to do here is I'm going to say age, space, Now space, it has space here, remember, which I'm going to strip off. It's going to be age. And then, of course, skin patches. This is how the person wrote it. It's going to be skin patches. And then lumps. It's going to be lumps. Nav. Nav thickness is going to be nav thickness is going to be nav thickness residence eyebrow loss is going to be eyebrow loss. Remember, I must put a comma. This is a dictionary. And then, of course, pain score. Let me just kind of remove this now, right? And let me just put something like somebody going to put an hash inside it, inside the header. And then it's going to have some temperature. And then the person puts something like maybe art sign inside it. And then it said this is about temperature. And then we'll say educational score, percentage. The person put percentage there, and then is education. Remember, I'm assigning it to what's actually contained inside of here. And then sorry, I always forget to use this. This is Monzo score. Now there's space here. And then I'm just going to, I'm just going to put some space here. Let me add extra space, double space, and then the person still put something like hash. Okay. And then what else? What else I'm gonna write? That's going to be muscle score. And then maybe they call it diagnosis. Okay. And then that is the result. Okay. All right, so that's how I'm gonna run it. Remember, you shift enter. So that's it, everything works. Now, the next thing I'm going to do in this video today is I'm going to now, so now that we have this here, now I think everything is actually ready. Now, what we'll do now is we'll now get our pandas. Now, that's what we're going to use our pandas now, right? So this is pandas to get our data frame. So what I'm going to do, I'm just going to go up and so see time to generate our data frame. So we'll call it data frame. So I'm going to call it df. Usually the normal convention is equals to pd dot. Now, if we wanted to import an Excel file, we'll use something like read CSV or whatever, or starter or anything. But that's the object to use here is going to be data frame. So that's what we're going to use. We're passing Now it's could take in a list. That's a list of lists. It's going to take in a list of dictionary. It's also taking a dictionary. So I'm going to pass in that dictionary there, which is the data set, this, because I've now converted it to a data set inside of, more like I've put all those things inside this data set here, inside of this dictionary. So that's it. So I'm going to run that and everything works. And so what I'm going to do now is I'm going to kind of df dot head. So let us see our data set. So I'm going to say df dot head. Okay. And that's it. Now, this is what our data set looks like. Now, and it's possible you can have this, in a data set. Now, what I'm going to do now is I'm going to convert. Now, let us convert it to an Excel file, Excel or CSV file, and then import it again. Okay, so what we're going to do is df.to, we use the method. That's the method we use to CSV. And then inside of it, now we're going to pass in the name that I want to give it. So we'll call it unclean data set, because we're going to see some mess up inside of it, right? Unclean data set. Let me just call it unclean leprosy data set. Now the extension for the file must be .csv. Now, if you're passing it as XLS file, an XLS, you're saving it as an XLS file, maybe .excel, that's to Excel. Now it can pass taking unclean leprosy file, sheet, or whatever sheet, .xls. It must take in that extension, Now, if it's a model, it could be maybe pickle, depending on whatever, right? If it's a neural network model, it could be .dict. But here, let's just use to CSV, okay? df dot to CSV, that's the method. Then we're gonna say unclean leprosy dot CSV. Okay. Now, if I do this, it's going to work. I can just to confirm. Now, I don't need to assign this to a variable because it's definitely it runs without assignment. So you can't assign it. So just to show that it worked, I could print successfully converted and saved. I'm going to print that, so it says successfully converted. Now, if I drag this part carefully, you're going to see it here. This is it, okay? And that's it. So let me just kind of show you that. Let's view it outside. So maybe kind of drag this out, and that's it. I'm just going to delete this, okay? I just like having a clean interface. Okay. So let's just gonna open this file, and then you can see it now. All right. So this is it. So this is the first sheet. So you could create other sheet. But what did you notice here? We're having a number here that is different from this, right? And it doesn't start from age. But if I want to kind of remove this now, this is what I'm going to do. So I'm just going to delete it entirely. I don't want it again. Then I'm going to go back there. Okay. Then I'm going to pass an argument here. I'm going to say columns is equals to false. I'm going to run it again. Hold on. I'm just going to say none. Sorry, I'm going to say none. Just to be sure, let me just kind of delete that one. Okay. And let's just kind of see that. And we're still seeing that margin. And hold on. I need to know why it's showing. So I think this index as false. Index as false. All right, so that's it. So let me delete it, okay? Hey, what did I do now? I think I've deleted it again. Sorry about that. Let me just delete this permanently. Okay, it's open somewhere. So let me just trash it so that I'll show you guys, okay? All right. Okay, so now watch. All right. Let me zoom in a bit. Okay, all right. So now watch. So you've seen the heading, right? So if I cannot, I'm going to set my index at false. You could set it at none, whatever one, each one works. So when I set index at false and I run it, and that's it, you can see it starts from age. Just to confirm, if I drag this out and then open it, and that's it. So you could see that that index, first index there, it's no longer showing. So I could just close it. And then you can see positive, negative, positive, negative, positive, negative, positive, negative, positive, 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 and all of that. All right, so guys, don't worry. I wanted to have shown you how to also get some logic, but I wanted this video to be so easy for beginners, just for you to have some much more clearer insights and all of that. So let me call this another name. Let's not call it DF. Let's just call it old DF. Okay, old DF. And then, of course, it still holds that param. I'm just going to call it old DF. And that's it. Okay, so I'm going to run all. Okay. Okay, now, so what we're going to do now is, now we've saved the file. We've created the data set. We've saved it. Now we're going to import it back and then do our machine learning training. Now, we importing it back is like we got it online and then we want now import it and now do what we call proper data cleaning. So this is more like a data science course now. So we're going to do proper data cleaning, remove all those nonsense inside of it, and then of course make it super. All right, so now that's what we're going to be doing now. All right. So even if you're watching this video particularly from this point, of course it works because you could decide to start your data set, your machine learning journey by importing a data set and using it. So that's also very, very much more obtainable. So whichever stage, whether you're starting from importing or you're starting by creating yourself, all of them works. So import the data set and perform some machine learning practice. All right, to kind of import that, we're going to say, I don't know if you guys want me to run it in a different cell. I'm just going to do that, everything in a different cell. So I'm just going to create a file. I'm going to say training new practice dot interactive Python notebook. So I'm just going to create this. Okay, sorry. So I'm going to select a kernel, and my base kernel is 20.5. And I'm just going to place all those dependencies here. Okay. So it's connecting to my kernel. So let me just do everything fresh here. All right. So there won't be time to queue that kernel. All right. So the next thing we're going to do right now is since we've now changed, we've now saved, gotten our CSV here, and then we'll have our new stuff here. So I'm going to say df is going to be, let me just run this, I'm sure that's working. So df is going to be pd.read CSV. And then, of course, we'll pass an unclean leprosy.csv. Okay. Now, if I want to kind of change something, maybe I could pass more other arguments here, but that's it. So what this here now is importing our reading our CSV. Okay. And then I'm going to now come up. So I'm going to say, now, what's the first thing you do whenever you have a data set? Whenever you have a data frame, the first thing you need to do is to check the data set. All right, so we'll do df.head. So that's it. Okay, so this shows us, what our data set looks like. Now, the next thing we're going to do is we could check the tail, df.tail. So it checks from the last 5 numbers, right? So that's what it means. So here is checks from the bottom last 5. Okay, the first here is checks from the top 5. All right, so now the next thing we're going to do now is we check, and the next thing you do is we check the, because already we've seen this now, we check the information about the data. Now, so we'll do df.shape, right? Now it's telling us that we have 1,600 rows and 1,600, sorry, and 11 columns. All right. Now another thing is we check more on the information. We could check df.size. Now, what is this? 16 times 7, 11 is going to give you the total number of items that we have inside of it. Let me just show you that now. So if I do calculator and I kind of open my calculator here, let me just show you that. So if I do 16 times 11, that's it, right? Now, the next thing is that we check the information on it, right? Now, more on the information. Okay, I think I'm trying to spell that properly. So we check the data type information of the data set, right? So how do we do that? Now remember, dot shape is a method, dot size is a method. This is a method. So we call it with a dot. So we will now do df.info. But it has to be called. This one now, we don't call it. We don't wrap it with a tuple. If you wrap it with a tuple, it's going to throw an error, right? Because you can't call it. You can't call a dot size method. Let me just stop that so that it doesn't throw that error. You see, it's not callable. Now, but the info here must be callable. So what does this give us? It tells us that the age is an integer, that the skin tone is an integer, that the lumps is a float value, that the nerve thickness is an integer, residence is an object. So what an object here means is, an object here means a string, a string. So whenever it's a string, then that means it's a what? It's an object. So float, an object, right? So you see that even our diagnosis here is what? An object. So that you will not say that I did it as 1, 0. Now we go do them ourselves. All right, so the next thing we can actually check here is that we kind of check the statistical summary if there are outliers. So we check the statistical summary. Now, guys, I want you guys to understand that from next sessions and all of that, we're going to be working on projects. So I'm going to be showing you how to, use responsive front ends, like React, and all of that to create some responsive front ends, that you can use in deploying models, and all of that. So it's going to be so heavy on, some real world projects, not we're going to be building real world projects. So that's why these things are really important because it's definitely going to be showing on your model, all right? So here, what I'm going to do is I'm going to say df.describe this. Please describe it. So what it's going to do is going to tell us that for the age, we have, we have 160, 1,600, that's 1,600 counts, that's each of them. Then the mean is 48. And then, but how are we going to know if there are outliers here? How do you know if there are outliers here? There aren't really so much of outliers because of the way we did generate it. It was synthetically generated. But we could decide to inject outliers, but you look at the maths, you look at this 25% is the 25% interquartile range, because when you spread the data, when you spread it, right? This is the interquartile range. That's 25th percent of the data on that range, on that particular interquartile range, right? And then we've got the 50% interquartile range, we've got the 75% interquartile range, and the max value here is 89 because remember we capped it from 8 to 9, right? So 8 is the minimum age to 90. So you can't get 90 because 90 is usually the cap. Remember, in machine learning, it doesn't give you the final cap there. And then come up for the skin patches, we've got stuff for that. But what do you notice here? It will only give you for the numerical values. You're not going to see diagnosis here. You're not going to see education here because those ones are strings. So strings are not part of it. So this is only for what? Only for the what? Numerical values. All right, so which are actually, I'm just going to say floats and int, okay? All right, so excluding, more like excluding object. So object here is what? str, string, is a string. All right, so guys, that's actually going to be that. That's what the next thing we check. So is there another thing we need to check? We need to check after when we get the data set. The next thing we need to check is we check if there are some sort of duplicates inside of it. So how do you check it? So I'm just going to show you now. Go say checking duplicates. I'm going to say df dot duplicated. So that's actually the method there. Duplicated. It's callable. It's callable. You kind of print checking this. It's going to give you a Boolean, but watch, if I do checking duplicate, it's just going to give the data frame, but in a Boolean. But what I'm going to do is I'm going to do dot sum, just going to be summary of all of them. So this is what we call chaining methods. So we can chain methods in programming. You know that. What do you mean? Chaining method is random dot randent. This random is already a model on its own, right? And there was something we did not do when we were creating the synthetic data set, which I did remember here now, is that we should have done something like np.random.seed. But no need to do that again because we've already saved the data set. If I run this again, it will give me another type. It will continue to change, but there is no need again because we've already gotten our data frame and we're already in a new layout. All right? So no need for that. Nothing is going to change. We've already picked up what we want. And that's it. So if you kind of come here and print, what is the number of duplicates in the data set? Okay, I just gonna not call the variable checking duplicate. 0, there is no duplicate inside of it. That's all we need to do so far whenever we get the data set. Another thing we need to now do the last thing we need to do is to check the type of values that are inside it. Now let me tell you guys something. Imagine that you want to train a machine learning model, and this asterisk, this slash here, is in the center, middle of the data set. You should be asking me a question: how will I know that there is a slash there? Because Python will not recognize this slash. It's still going to call everything a string. But how will I know that there is something unique inside of it? This is what we're going to do. The type of data that is inside it, because automatically here, if I cannot do if I do df dot head, right? Maybe I do something like 23. You see that there are some kind of asterisks here. Cool. All right. So what I'm going to do now is I'm going to go back here. And I'm just going to delete this because that stuff was just trying to spoil everything. So look at what we're going to do. Now, to check, because we're going to be working with a lot of data sets. Now, to check the content of the data set, right? That's more like if there are unique values, because something can be hiding somewhere, we're going to do df, so I'm going to say calls, that's the columns, is equals to df dot select data types. And let's not do that way. Let's just do calls. It's going to equals to df dot columns dot df dot columns is going to give you, first of all, watch. df dot columns is going to give you all the columns. When you say df dot columns, it will tell you all the number of columns. So let me rewrite this as check the column names. So this is what it's going to give you. It's going to tell you the column names. Now, if I want to see it as a list, I'm going to do dot to list. It has now shown me this as a list. And the reason why we do this is that the reason why we convert it to a list is so that it can hold the attributes of a list. And whenever it's holding the attributes of a list, we can start to perform some operations that normally we can do in a list. Remember when I did teach programming in Python, I do have a 12 hours course on programming in Python. Links in the description. Now you're going to see that when we went into list methods for lists, there are a lot of methods that are in use, right? You could check the length, you could remove items from the list, you could add, you could do a lot of stuff. Essentially, you could do so many things inside of the list, right? So that's actually the reason why we do this. So that's it here. So we continue to go. And the next thing I'm going to do here is, I'm going to now do, since I've actually kind of found the list actually in this video, the next thing I'm going to do right now is, we're going to check if there are unique contents inside of the data set. And to do that, I'm going to say df dot, df, we're also going to say df, for say calls, is going to be df dot columns dot to list. Okay, so we've assigned this now, all of this now, to a variable called columns. So I'm now going to say for call in calls, what does this thing mean? For each column inside of this particular place now, stay with me. Now, I'm now going to do df of co. So I'm going to say print co, just the column, give us the column name, then give me df of co dot unique, right? So I need the unique parameters here. Okay, don't worry, and I'm going to print, just going to print something. No, separate it like this. Now, before I run this, let me show you something. Let me show you how to check the unique values. Now, remember, when I did df dot head of 2, or maybe of 5, you saw this as, what's happening? It's kind of changing. Let's just be sure it's not changing. Okay. All right. This is 10. All right, cool. Now, remember, when I actually did this with some show of something, okay. All right. Now, I want to show you guys something, all right? Now, if you watch this here, if I want to check if I want to check the unique values inside of residence, look at what I'm going to do. I'm going to do df of residence. Now, this is what we call the bracket notation to assess each particular property. I'm not teaching pandas because I do have a full video on pandas. You could check that out on my channel. Now, if you do that and say unique, watch. It's going to tell you that, okay, what's inside of this data set? We have rural, we have village of star, we have urban, we have city, and all of that. Are you seeing how this thing is working? That is how it gives us the unique values that are inside of this. So that even if I don't need to do df the 1 million to show me, go through everything manually. I just need to pick it series by series and check. But if I'm checking it series by series, it's going to be stressful. Imagine we have like 20 columns or 200 columns. How am I not going to be checking the unique values in each of them one by one? It's going to be hard. So that's where we'll now come to use this. We say, for calls in columns, give us this, and then do df the unique. What happened here? Oh, it didn't show us that. I think just print this. And now you see what happens. So it will now, look at what I did. Let me explain the code. Now this is the for loop here. Usually you can iterate over a list. This is just a list, right? Good. And then this is what? Print each of those columns. Because normally you could do for this in the print code, it will print each of them. So when it's running for call, first of all, it prints the first column. It will print the unique value of that first column, and then it will print this block. Now, it will go over to the next column. Because remember, it's a list. It will move from age it will move from age, that's the next column, right? Which is screen patches. It will print that column. It will check the unique values that are inside of it, which is this, and then it will give you this. It will move to the next column, lumps. This is what's inside of it. There's no special unique value inside of it. If we had something like an asterisk inside of here, it would have actually brought that one out. And it does the same for nav thickness, for residence. We can now see, oh, there is asterisk here, or there is slash here. And then eyebrows. Wow, I'm having none here. What is none? Python treats anything that is none as none. Okay? Then that means, because in real world, you will encounter dirty data sets. You're not going to get a clean data set. You're not getting a clean data set. No data set that is going to be given to you is going to be clean. It's going to be so messed up. Now here you see we have pain score. We have this okay. So now it's clear to me that the places where I have nonsense, where the people filled inside of it, is in residence and also in 1, 2, 3, 4, 5, 6, 7, 8. I think there's a missing column. Is there any missing? I hope I'm not missing anything. Eyebrow loss, is it there? Okay, is there? Lumps, is it there? Age is there. And then skin nerve thickness is there. Educational score, is it there? It's not there. So we need to know why it's not there. And okay, so what we could do, okay, I think it's supposed to be there, but it's hiding it here. So let me just reduce this window face again and run it. And how to show this now is what we're gonna do now is how many at the center is not there. Education and muscle score. So what we could do is I'm just gonna print some calls is equals to I think when we chunk okay, all right. Sorry. So yeah, so we just you see we could truncate the output. So it's scrollable. All right. So that means this is it. So you see education is there. And yeah, so if you kind of come out from here and run it again. So if you want to see it scrollable, you click it here and then it's going to now scroll. You can scroll on it. So you see education, we have dash and we have none. Temperature, we don't have anything. We have all the numbers that are required. So that's actually that, guys. You know, so what we will do next is, since we have all of this now, we're now going to start our data cleaning. Okay? So let me just kind of bring this thing up again so that you guys can see what I'm doing clearly. So we'll start our what? Our data cleaning. So what do we do? The first thing we need to do in our data cleaning is we need to clean. So we can start from anywhere, right? We can start from anywhere. We can clean our columns properly, and we can now start removing all the duplicates if there were duplicates. But then just to show you how do we remove duplicates, we say df is equals to df dot drop duplicates. Of course, we could say in place equals to true, and that's it. So that's if we had duplicates. So this is the method. This is to remove duplicates. All right, so that's because I've actually run that before. So it's now none. It's now none. There's no duplicate there. So that's why it's showing that. And so there is no duplicates, of course, because when I say df.duplicated, print checking duplicate, you see that that's 0, no duplicate. So let me just take this up here. All right, so all right, so the next thing we're going to do now is if we do df, no, let's just run all. All right, so if we do df, right, we're going to see that we have some messy column names. So let's change the column names. Let's standardize it. So we're going to clean and remove wrong column names. So it will be easy for us going up from here henceforth. Do you understand? All right. So let me just put a mark down here as data cleaning. All right. So cleaning column names. So that you guys can have this. So what I'm going to do now is if I say df.columns, so this is it. I don't want all this asterisk here and all of that. So what I'm going to do is df.columns is going to equals to df.columns dot as type. Now we need to convert it to string, right? So it means that what we're doing here now is we're using this method to refer to each of these columns here as a string. Now not say dot. We need to any action we are performing with the string method, we need to continue to call that any action that we are performing now on that particular data type. Now we need to continue to call it. So say dot string dot, first of all, lowercase, right? And then dot string dot, to remove these spaces here, we use what we call strip. It must be wrapped with a tuple. Now dot. Now let me show you what it looks like. Now let me run it and say df.columns. Now you see, as type string, it converts everything to string. And what you could see here is you could see lowercase, everything that is now in lowercase. Strip, what strip did was it removed the external space. There was an external space. That's what it did. It removed the one particularly for age. But now, this internal space here and this hash, how do we remove it if we see it in a data set? Okay? Stay with me. So say again, df.columns dot. Now we say it's now because it's holding the variable here. So say df.columns dot string dot because it as type string, of course that still works, but say but as type string dot string. Now how do we remove this space here? And how do we add an underscore here if we want to? Now, the first thing I'm going to do, first of all, is to remove this double space because this is a double space, and then remove this hash. Then I'm also going to add this. So what I'm going to do now is the string dot replace, watch, replace. Then I'm going to now, instead of this replace, then there's something we call regex methods, but don't worry, I'm not really going to go so much in details for that. But just important for you to also activate it whenever inside as a parameter that's inside of your tuple. But I'm going to say space, double space now. Any double space here, comma, change it as nothing. That's what this thing means. And then let that regex be false. Don't worry, where we talk about regex is because there are some special strings. There's some special strings in Python, which more of regex values. So the reason why we're saying as false is don't try to use this thing as a special string. That's why we're activating it. So if normally I do remove this, of course, it's still definitely going to run. So let me just kind of run that and show you df.columns. Now, the only thing that will leave here now is this double space. But let's check. So run it. So you see, there is still space here. Now, the double space that's at muzzle score, it's gone. So that's it. You see, it's gone. But we still have asterisks here. We have at here. We have two words. We want to join them together. So we can easily use dot notation in accessing them. Look at what I mean by that. Normally, if I do df dot age, right? Then I say dot maybe something like dot sum. Now, what it did here now is that it gave me the sum of everybody on the age series. Now, but let me say I want to do for skin patches the sum, and I want to use this dot notation. Now, you see that I cannot do something like df dot skin patches. You see, it's not possible. Because of what? I can either use the snake case, or what we call the what? You know what I call by the snake case? We have the snake case. I did teach that particularly in variables. Now we can't declare a variable like this, right? So if I cannot use this dot underscore here, this does not exist because there's no variable like this, right? There is nothing like that. So it means that we need to kind of, that's what we are trying to standardize this to close up all of this, close all of this. So we can use the object sort, we can use the dot notation to access parameters from that variable. But here we could say age, we could say df dots. If we don't want to use a dot, we could say something like this. The bracket notation, skin patches dot sum, of course, it's going to work. So that means we are only restricted here to using this part. Because if I confirm by saying df of age here dot sum, let's say you're asked to get the sum of all the ages of all the patients, of course, it still works. It still gives you this. So it means that the only way I can be able to use the dot notation here is by converting this to what? To a dot. That's why in variables, we either use what we call snake case. So what do I mean by snake case? By snake case, I'm saying name is equals to, no, not name now, I see something like maybe name of school is equals to maybe Nigeria, right? Nigeria school or whatever, Nigeria school. It's just Nigeria. Let me leave at Nigeria. The idea here now is that this variable here is a snake case, right? This is what we call snake case. Whereas camel case is what we now say name of school is equals to Benin. So this is also advisable on this. We can't do something like name school. It's a syntax error. It doesn't, you see, it's already throwing up error. So that's what I mean by that. All right, so I think that's just that. Let me just kind of delete that. We don't really need it in our documentation. So what we will do now is, so how do we put that? So let me just kind of scroll up slightly. So in order to do that now, so we'll now say again, df.columns is not going to be equal to df.columns again. Now dot as type string, then dot. This is what we call method chaining, right? Now dot string dot, please replace anything that has space with an underscore, right? We're going small. Now, I might want not, let me not put that regex there so it doesn't confuse you. Then let's check. Cool. Now it has now replaced everything now with underscore, but we still have hash here. We have at here. We have percent here. I didn't want, I would have changed everything at once, but it might confuse you. But I wanted to do it was small, gradually, so that you will see how I'm changing it. So how do we now remove this now? Because here we've added underscore here. Remember, if we have wider spaces, then let's say we had double spaces in between, I would have just added a double space here and then do a one for the double too. It still works. Or I'll change all double spaces first to one single space. Triple, double, everything, I'll change them to double single space before I'll now change the double to the single now to underscore. Look at what I'm saying. Look at what I'm saying. Let me explain what I'm saying. Let's say I have something like maybe somebody said class category as a variable. Now, what I would have done is I would do df.columns dot is it going to be equals to df.columns dot as type string, because it has to be a string and it has taken that parameter, then string dot replace. Then I'm going to do space of everything double, change it to single double, dot string dot replace again. I'll say everything maybe two double, replace it as single double, dot string dot replace anything that is double, replace it as single double. Then the idea, what I'm trying to do is, let me just try and force everything possible to be at only one single double. So when I will now come, I will now say dot string dot replace every single double to underscore. Because if I kind of do this now, maybe if I just say everything single space to double, anything that is more than this, it will still remain there. So that's what we need to actually understand our programming procedural paradigm. So I'm just going to delete that because we don't really need it. We don't have any business with it. So let's kind of change this now and remove all of this now. Just kind of take out all of this now, right? And so it's going to be normal, right? So we say df.columns dot, it's going to be equals to, I don't know why I just scooped in that, df.columns dot as type string dot replace. Now, so we need to pass string dot replace. You must pass this, so please make sure you do. And then now any hash change it to nothing. Remember, I didn't put double here. Just change it to nothing. And of course, regex is equals to false. That means just off anything regex. Or you could change this to, if you don't want to use false, you could use none. It's still going to work. Say false, and then dot string dot replace anything. Is there any asterisks inside of that place? Anything at, replace it with nothing. I didn't put a space here of single double. I just, nothing will be there. And then regex is going to be equals to false dot string dot replace. You can chain all of them at once. And then anything, what else do we have? Percentage, replace with nothing. Regex is definitely going to be false. And then df.columns, in short, dot to list. You need to be very careful. That is actually a different method. And that's it. So you see that we now have this, is a df.head. Sorry, I didn't spell correctly. And that's it. So this is how our data set now needs to. Now, if I kind of do something like df.skin patches, and no, not sorry, not this, dot sum, And then that's it. You see, that works. That dot notation assessment. All right, guys. So that's definitely going to be that. Now, not really so much to waste your time. I don't really have that intention. So the next thing we will do here is we will now need to now clean up the data set, because remember that when we did our calls as df dot columns, right, dot to list, and then we now set for call in calls, and then it was we now set print call, and of course df of print df dot, because we have to print it, print df dot code dot unique, and no, that's, I think, unique against that well, and print something like maybe just kind of something like this. Let's put down. Okay, the mistake is here. It doesn't have an attribute, so just wrap it here and dot, and that should work. So what it means here now is that we kind of see how we have a couple of things to do. We need to remove the undesirable characteristics inside of scheme, not scheme patches now, inside of residence, eyebrows, and muzzle score, educational score. Now, so we're going to clean up those columns now. All right. Now, this part will require that we'll do it one by one, because you can't really do it together with a loop, because you can anyway, but the point here is that you don't want to make any sort of mistake. All right. So let me just do it one by one so you guys will understand it very well. So I want to remove this dash here. I want to remove it. Now, so what do we do to it? Now let me tell you something. Let's say you're doing maybe a sort of programming exercise, or maybe you're giving a machine learning model to train. And for example, now you have some participants here that filled nothing. Or maybe at the end of, let's say a patient was in the hospital, and then at the end of the day, there was nothing to say if this person was positive or negative. But then we'll have all the whole information on history, age. Pay attention. We'll have the age, we'll have the BMI and all of that. But then at that particular last age, nothing was said. Now, what do? Do you look for something to fill it up? Because, when we talk of data cleaning, it kind of looks as though something magical happens. We use our logic in cleaning our data. So if it is something of age, maybe we can just clean it up by assigning the nearest age to it. Or we can, what we call missing values. You pick up a questionnaire, somebody did not fill something, you kind of help them complete it. That might be okay in terms of some certain features. But when it comes to your target, you don't joke with it. You don't fill up somebody to be negative or to be positive. It's a blunder. In short, if you train any machine learning model with that means you're going against ethics and you're setting yourself up for disaster, because it doesn't make any sense that we have an incomplete data set where people filled in nonsense, and then you're trying to clean it up, and then you're kind of assigning something to it. Maybe somebody said slash, you have to say, oh, the person is from this city. Well, that might work for residents or something like that. Maybe where we fill it with the mode the most frequently occurring one, we can fill it with it. But then when it comes to some critical values like status, instead of us filling it with something, the most frequent or the mean or the median, we drop all of them, we drop it. Okay, we drop everything. All right, so but it was very important for me to talk about this part because just so you have an idea of what we're doing, even if you haven't done it before in your entirety of your existence. So what I'm going to do now is I'm going to start with residence. Okay, so let us handle this bracket. This is the only thing we're handling now. We're handling this asterisk. So how do we handle it? So to assess a series, now what do we mean by a series? Everything you see here is a data frame. Only this one, only age is a series. Age and skin patches alone together is now a data frame. But skin patches alone is a what? Series. Just so you know. Because if you print, let me show you that. If I print type of df of age, it's going to give me series. But if I print type of df, it's going to give me data frame. I hope that's clear. Now, if I kind of print something like age and skin patch, I'm sure I spelled that well. Let me just put diagnosis, for example. It's still going to give me data frame. But if it's just age, of course, it's going to be one bracket series. Okay? All right. So we're going to access the residence series. Now, similar thing, if it is a string, how do you clean it up? Now, participant has filled the form. How do you clean it up? We're going to do the same thing that we did when we were doing the columns, something similar. So we picked up the series, that's residence. So say df.residence dot as type string. So why do we say as type string? Convert everything to string, everything inside of it, change it to string. Don't, if it was float, if we were having numbers inside of it, trash everything into string. Then I will now say dot string. Now let me show you something. Let me show you something, guys. Now inside of this now, you're going to see that we have village uppercase, village lowercase, urban lowercase. So it means that we can decide to keep everything uniform. So let me just kind of show that here. Let me say df.head. So you'll be seeing it. Okay, so what I'm going to do here, the string dot lower. So what it does is it changes everything to lowercase dot. That's everything inside of this residence column. Then dot string dot replace. Now that is where I'm now going to put that asterisk to what? np.nan. np.nan means what? Nan values. That's what it means. Nan means what? Nan means what? Not a number, right? So it's easier for us to handle when we're going to fill all the, because there's a method where we call fill all the nan inside of this column. Fill it. Remove. But first of all, for us to fill it, it means that we need to change any nonsense into what? Nan. Now, let's pay attention to this asterisk here, because we saw in our unique that there are some asterisk inside of it. So what do we do? Dot. So let me just run this first. Okay, so let's say, what's that? String is not callable. String dot replace as type string, and then dot string dot lower dot string dot equals regex equals to false, and string. Okay, replace must be a string or column. String dot replace. That should go through. What is the problem? Let's check. Dot string goes. Okay, so let's do df dots ahead. Now you watch. Let's do df of residence dot unique. Now you see, I have now replaced all of these with what? None. So it means that all of them are now what? None. Now, and I've also changed everything to lowercase. You can see it here now. So, but we could do df dot residence. Now, I will always advise you to get conversant with using the bracket notation. It's good practice. It's good practice, right? But you could still use the dot notation. I'm just used to using both string dot replace, and then we'll pass star with none, I guess, equals to false. Let's see. Okay, so let's copy this now and see what's going to happen. What's the problem? A string tier of residence dot unique. So you see, I have now removed the what? I have now removed that what? Asterisk inside of it. Now let's kind of check if df of village dot size dot shape. Let's see if it's going to take dot shape. Df of, I don't know why this thing keeps wasting time. Size. I didn't spell it well. Oh, sorry. Oh, I was missing residence. Okay, so you see, it's still 1.6. All right. So it's clear now. Everything is usually clear. So means we need to now go to the next part, which is so we've cleaned up the residence. We've now changed everything to none. Anything that is not village. So anything that is not proper, somebody feeling something, we just change it to none. Don't worry, we'll still handle the rural stuff and village and urban during our pre-processing. That's what we call pre-processing. For now, what we are doing is what we call cleaning to make our data set clean. So for now, because if you tell me that is clean, it's not, because some people can decide to handle the data in a different way. You understand? So some people can handle rural, semi-urban, and all of that. So it all depends. So another place that we're going to be looking at here is, so we've done for residence, and then the next thing is our what? For eyebrows, we don't have anything to do there because automatically it gave us none. But for temperature, for educational score, we are going to remove this asterisk there. So I think that's actually what we're going to be doing. So say df of educational score. Is that correct? Just to show that's what I called it. Educational score. Okay, crazy. I called it educational score. Is df of educational score dot as type string dot replace, and then we'll pass in dash as nothing. Okay, that's np.none. So regex is equals to false. Replace must not be callable, so just remove the string and it works fine. So say tf.educational dot and what I'm gonna say, educational score, and just put it inside of a bracket, educational. Let me just copy this, don't worry. I'm too lazy to type dot unique. No need for some. So what I'm going to show you is another method. We could say dot value counts. And that's it. So you could see the ones that are none is 307, secondary is this, and all of that. Okay, so that's actually going to be that, guys. If we still look at our data sets, so far, Pandas cleaning is really very much important. And just understanding how to work with data is something that is very, 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 very much important. So what else do we need to do? We need to now fill what we call, we need to know what we call handle non-values, or what we call missing values. Okay, so that's what we're going to be doing. So df dot. Now, how do we check overall missing values across the entire data set? So we say df dot isna dot sum. So isna means is there an value? So we're going to run that, and that's it. So it means that in eyebrows, we have three non-values. In educational score, we have this. But this is wrong because in residence, we should be having non-values. And just to be sure, yes. So what we should have done here is to say dot replace, we have none as np.none, regex is equals to false, of course. So let's run all. So expect to have here residence and what's the issue? I said without frame object has no attribute. Educational score. Why? Okay, let's put this in this. What's the issue? Invalid syntax. We'll check. Where did I make? Okay, the dots. KL. Are you sure the name was educational score? What did we call it? Educational score. So check. It's in KL, educational score. Mm, wait, hold on. At this point, let's check DF. Oh, something didn't run. Something's altered somewhere. I think there was a mistake I made somewhere. I mistakenly left something without uncommenting it out. That's why the whole underscore has gone out. And space to this. I think this is where the mistake came. All right, so it should work now. Okay, it's back. So put this here. Fantastic. And that's it. So we'll do something like this. Let me just show you guys something. So we're going to say df of residence dot value count none. So that none is what we're trying to, because if you're not careful, it's not going to show here. So we're trying to handle that none properly because we're supposed to have some none there. And that for residence. So let's check what we called it when we are filling it. Right, so that's what I'm checking now. Residence. Okay, there's no non-value there. There is none. So we converted this square here, and then we moved to address that. Okay, so we go up, we're in the right direction. String dot replace. Okay. Okay, so what we're going to do right now is, okay, all right, now, so the reason why we need to have that non-values there is because if you look at when we are creating our, well, let me bring this thing here. Yes, this is the right place for it to be. So if you kind of check out the entire process here, and find out that education, 337, eyebrow loss. I'm just trying to debug residence and no, this is more important. Zero. Then all right, so look at what we're going to do anyway to find that out because we're definitely going to do our pre-processing. So of course we'll definitely get that there. So what we're going to do right now is we'll so df of, I'm going to say df dot fill. Now let me explain something to you guys right now. Now there's something we call the x and x. There's a particular method that requires us to select data types, right? And what we're going to do with that is, take for example, now I'm saying df dot now I'm saying df of residence. Let me check something. A string. Good. So we have it here now, right? And for educational score, dash as np.now. Probably this is from my kernel. This might be from my kernel because or I didn't save. Beautiful. So this is what I want, right? So cool. So we have our none for our residents. I think it's for my kernel. Each time I try to refresh it, then some of them up because I literally ran this command up. So I have to target the word none since it was what it changed it to, and then to replace to that. So if I kind of do df.head, or maybe I'm just do df.tail of 10. Good. So you see we have the correct none values. Now, what I'm going to do here is you still see that some of these values here are in capital letters, right? Like educational score, uh, this, diagnosis, and all of that. So it's easier for me to change everything together to lowercase. That was why that none was not showing. The reason why that none was not showing was because I I changed it to lowercase. I changed it to lowercase, and that was why it wasn't showing. So, but what I could do here now is we could handle the non-values, right? We could decide to handle the non-values, and then how do we handle the non-values? Usually, what we usually do here now is we'll fill it with what we call the mode. You know, in statistics, there's something we are usually taught, mean median mode. And the reason why you're being taught all of those things is because sometimes in machine learning training, or maybe a model evaluation, or maybe any sort of something, you know, it's kind of very important for you now to now know that when you look at the data set and there are some missing values in some features, you can easily use the median value to replace it. Or you can easily use the mode as the most frequently one to replace it. So what you need to understand is that for string variables, we usually use the mode because you can't use median now because it's not numerical. All right, you can't use mean median. So you have to use the what? The mode. That it's what's the mode? The most frequently occurring one. Change it to what that's any space that we've got, change it to that. That's just how it works. So I'm just going to do that before I now kind of change everything to lowercase. All right. So right now we have a clean data set. All the values are in a for field, and just we have some missing values which are none. So what we're going to do now is I'm going to now say that's for the categorical columns, right? Now for the categorical columns, maybe you could call it cat calls is going to be equals to, now we're going to say the data frame dot select data types. So what do you mean by select data types? Now we want to do for the categorical, then we'll still do for the numerical. Okay, so select data types include just objects. That's it, dot columns. So let's print categorical columns and see what it is. Residence, eyebrows, this and that. I see it. So this might be complicated for somebody to do, right? But the reason why I did it is because if you have 20,000 rows or columns, you might not have to be checking it one by one manually to collect it. No, this is the function. So what this select here does is select a data, a particular type of data that include only objects. You know, objects are the categories. Now, if it's that you have so much of categoricals and you don't want to use include, you can do something like exclude, maybe here you can say float, maybe float 64, and maybe exclude and exclude int in 64 and all of that. Just take out this, take one exclude. Dot columns. Dot columns. If I just kind of take out this now. Number, and I can use number, I can use float 64. You see, it's going to give you all of those that's not float, and you can only pass your comma here. So int 64, and that's it. Or maybe you could have maybe something like int 32, but they actually require a number of params. So because of that discrepancy, you can still just include only object. So if you do exclude object, it's going to just give you just the numbers. So age and all of that is a number, right? So, but I'm going to include object, and that's my categorical columns, dot to list. So I'm converting it to a list. Now, but I don't want to have this, right? But no problems about that anyway. If I want to remove this now, I could do something like maybe new cat calls is going to be cat calls, or I'm going to just rather say cat calls dot remove shall I say something like say new cat calls is equals to cat calls dot copy, and let's just check fruits is equals to, let's just check something, banana, apple, mangoes, and then we'll say fruits dot copy. Of course, that's it. It's a method. So we'll now say here new cat calls dot remove what? So dot remove diagnosis, okay? So that's going to work. So if I press new cat calls now, you see, this is what I need. But for now, we're not going to be doing that, right? So I'm just going to delete all of this. All right, so guys, so what do we want to do? So I'm just for calls and cat calls, I'm going to say, so I'm now going to say df of, let me just call this call. Df of call is equals to df of call dot as type string dot lower. Okay, so this is what we're going to use to lower all of them. But what I want to do now is I want to kind of remove the I'm just comment that out. So I just want to kind of remove the none, right? So I want to remove the none values. So let me just run that. So I want to remove removing none values from. So we're going to use mode. Now the reason why I don't have any issues not dropping this part here, diagnosis, is because it's complete. There is no missing value inside of diagnosis. If there was any missing value here, would have dropped it. So just so you get the logic here, all right? Because normally what you would have done here is we'll just print out cat calls. Let's say, for example, cat calls. And then I'll just take this here, reassign it again to say maybe cat calls is equals to this. This is good practice. This is good practice because you don't need to have what's this thing? You don't need to have diagnosis in it. It's not supposed to be part of the. Sure, that one is another part of the data set. It's the is one of the target variable. So what I'm going to do right now here is, since I try to have that, good practice, we follow good practice, still good. But I'm just going to remove it. I just want to remove the drop all the none values. Then what I'm going to do here is just going to run all to see that everything works. Just give some seconds. All right, so if we check our cat calls, okay, we still have diagnosis there. So what we're going to do now is to remove that none values. We're going to see for call in cat calls, we use a for loop. They will now say df of call. That means each of them, each one. This is still something as saying df of residence is equals to df of residence is equals to df of call dot fill NA, that's fill the non-values then, as use df call dot mode, and that's it. So we could have something like in place equals to, but no need for that. So we run this, and that's it. So what we did here now is that we filled all these non-values in the categorical columns with the most occurring one. All right, so we could now say tf dot isna. Let's check if there is isna dot sum. So let's just kind of print any num. What is the number of non values? I think I made a mistake here. I'll just wrap this. So that's it. So what is the number? Okay, let me just put this on a new line. So what is the number of the data frame here? Age. What is this? Not funeral with df call dot mode. And wow, our code didn't run. So cat calls is this. Okay. Then for calls and cat calls, df of calls, fill NA with df of that dot mode. And I don't know why. All right, okay, so look at what we're gonna do now. I need to know why, whether my kernel is stopping it. All right, okay, so let me just that's beautiful still. Let me show you how we can change that manually. So let's say residence. We're gonna say it's gonna be equals to df of residence dot fill NA with df of residence dot mode. So let's say, let's do the same thing for eyebrows. So this is df of, okay, let me just copy that. Dot mode. And then let's do the next one, df of educational score. I'm just going to copy that. Dot UNE. So that's a function. Just going to draw that down. That's what. So df.isna.sum. This non-value seems to be very stubborn. Or because we converted them to string. Okay, what we're going to do now is df.head. Let's look at it. And we can't use mean. Something is somewhere wrong because we forced it. So this is actually exactly how we do convert it. And I think when we are doing that replacing, it requires me to trace the bug from up. So, but just that is just how it's done. You understand? Yeah, so we convert this to string and we check the unique. Let's trace it. Okay. So at this point, we have all our duplicates. So we clean the column names, and of course, these are the column names. So that's a fly trying to distract me. So these are the column names, and then we strip it off, we lower, and of course we replace. So it shouldn't be coming from here, and then we replace as well, and then we have our skin patches, thickness. So when we now come to this point, we saw that there are missing values. And then we see residence as string dot lower dot replace this with np dot none. And then we got this as none. Then we did the unique. The residence dot size. Get our data frame again. We do for educational score. And then we do for handling non-values. And then resident. Sorry, we do. So we check out our residence, the value counts, and then we get the sum. We get the sum. So let's just take this down. Then we go for df.tail, and then we get our cat calls. And then we have our for loop. Okay, so let's use another approach because it requires me to take some time. So I don't really want to waste so much time. And say forward fill, backward, forward fill. Okay. For face not defining. df dot okay, dot sum 0. All right, so that's fine. I think this might be coming from my kernel, maybe from my kernel. So I'm going to explain what the forward fill and backward fill means. Because this method is particularly deprecated, it's not deprecated, and most of what we're going to be doing in the future is we're using the object of dots, maybe dot forward fill, and then we're passing what it's going to be. Now, what this means now is that, watch this eyebrow here. When we mean forward fill, it means that this no here is going to be replaced with no here. All right? That's backward. So let's say you have, let me just show you what I mean. df dot, let me say df dot head, let me just give it 10. Now, this place here, this line here, when we do forward fill for eyebrow here, what's going to happen now is that on top of it will become y. If we do backward fill, under the here is going to be no, under here is going to be yes. But if we do, now the reason why we must do both backward and forward fill is so that we can be able to, if we have a noun that's at the beginning here, it means that if there is forward fill, that means there's no stuff on top, so it can use the backward fill. All right. So this is what I'm going to do now. So that's for cat calls, right? So I'm going to say for calls in cat calls, but let me just do it for, this eyebrows. Eyebrow loss dot is going to be equals to df of eyebrow loss and then dot fill NA, right? So they said that the object here is now this thing dot, you see dot forward fill. That's the new recommendation. If it's backward fill, you use BFF. So, but if I use maybe forward fill, and then I think that's just that. You don't have to pass any other thing. So this is it. This is the object to use. You see that deprecated, that one enough deprecated is not going to come out. That's one of the things with Python. As time goes on, it continues to update, changes are made. Now let me show you now. Now watch this particular site. Let's say df dot head of 10. Now you see that I filled that right. Now look at eyebrow here. Now watch closely here. You're gonna see we had a none here. So it has now filled with what? Yes, which is forward. So that is no forward, no forward. Backward is going up. So if I did change it to backward, then it was going to be yes, because backward of it is what? Yes. So that's actually how we do it, but very, very important. You do the same thing for, and that's going to be df of eyebrow dot backward fill. Okay, so I'm just going to do that for all others. Maybe let me just complete this with the old style. Method here is backward fill. So it says it's deprecated, future warning, but it will run. And then the last one is definitely not pin score. It should be, I think, residence. So let's check df.isna.sum. It should just be one. Okay, that educational score is left. So I'm going to say df of educational score is going to be equals to, I'm just going to copy this now. So the object here is this. This dot forward fill, and then I'm just going to copy that, and then we'll do backward fill. So df.isna.sum. And that's it. So we've cleaned up all the missing values. But then, guys, the most appropriate way is usually this. But I'm just going to check out this problem at the end of this video, to know where that's. I don't even really want to take so much time trying to fix out. So we could use the forward fill and backward fill, which is very important. But it's more like gambling. It's okay, let the last number be what it's going to be and all of that. So, but it's applicable to it because it's short, you can find it here now, so you should know that. All right, guys, so that's basically that. I like to look at my data frame all the time, and the only thing we'll do next now is to now change all of this now to lowercase for all the cat codes. So I'm going to say for x inside of cat codes now. So I'm going to say df of x is going to be equal to df of x dot as type string dot lower. I think that's all. So when we say df dot head again, and that's it. So you see everything is now in lowercase. All right, so I think that is basically that, guys. I'm seeing some nan somewhere. Who is this? Let's check. Okay, so what we'll do here is df dot it. Lesson. Okay, so what we'll do is going to be equals to hold on dot as type string dot replace now np dot now. So we'll run all. Okay, so say df of, just to be sure. So I'm just going to say cat calls. Let me see what they are. Okay, So I'm going to say, let's just check out everything inside of cat calls. So I'm going to say for x in range, cat calls. I'm going to say print the call, print x, then print df of x dot unique, print let's see. Okay, so we have rural, city, village here. We have no ESC, right? We have primary, tertiary, secondary, and then that's it. So I mean that we don't have any but some. And that's it. So, all right, so you need to be very careful. You continue to check. That's why we call it data cleaning. All right, so the next thing here now is some pre-processing. We're going to be doing some pre-processing. And of course, I'm going to call my DF again. So you'll see that. And so what do we need to do now? Now, we need to now do some encoding, right? Proper mapping and encoding, pre-processing. So let's our pre-processing starts from here. So that means all I need to have rural and urban. Anything that is not urban, take it away. One song just came to my mind. Take it away. That's really the sing it. I think that was maybe it was a church or something. So but what you're gonna say is df of that's going to be residence. It's going to be df of residence. So I'm just kind of reassigning it to that, okay? So just feel free to do what you want to do. So df.map. So you pass a dictionary inside of it. And of course, rural is going to be rural. So this is what we're using the map method to do. And then anything that is village is going to be rural. And then anything that is urban is going to be urban. So I think that is just it. So I'm just going to run this, right? And just feel free to do what you want to do. I think I'm supposed to encode this here as well, but I'm not really going to do that because of just so you see. Okay, let me just kind of show you what df is now. So df dot head. You see that I've kind of so let's just confirm by saying df dot residence dot value count. So that's vectors chain. So you see that we now have only rural and urban. Okay. I think we're supposed to do this again for eyebrows. I'm just gonna delete this stuff here. We're supposed to do it here. So we'll say df of, how do I remember? Eyebrow loss. So if I do eyebrow loss, it's going to be, let me just kind of copy this because we are reassigning it to that variable, okay? It's going to be df of that and then dot map. So that's what we use by dot map. So if you don't know what dot map is used for, you could just look up my full Pandas course. And what are actually the parameters inside of that for the map? This is where you could copy it. So we'll copy it now, okay? And I'm just gonna kind of just because you remember you must pass a dictionary inside of it. You must pass, if you don't pass a dictionary or you wrap it in the tuple, it will not work. So no is going to be no, and Yes is going to be yes. And anybody that feed in Y is going to be taken as yes. So that there won't be any confusion. So if I do df dot eyebrow loss dot value counts, we could just solve value counts. Yeah, it's a tuple now, so you could see that that's it. So it works. And I think we're kind of unraveling some patterns gradually. And if you just do df dot show, no, that's df. Just going to df, okay. So you see that everything works well. Here we have primary. So we're going to be doing what we call encoding. Now I'm supposed to teach you one how to encoding, but I do have a video on that, full video on that. So, but then I'm just going to do the normal encoding. This is the part of our pre-processing steps. Now, what does encoding mean? Encoding means that oh, sorry, I don't know, I think that is quite small. Now, what encoding means is that all the parameters that's going to be used to train this machine learning model must be numbers. So here we have rural, urban, here we have yes, no, we have primary, tertiary, we have diagnosis as positive, negative. Remember, we don't really touch this part. We don't touch it too much. So what we're gonna do now is that we need to convert them to numbers. Okay? And how do we actually do that? So how to do that now is I could have done something like maybe I'm just gonna run everything to be sure at this stage we're all code. Okay, all right, so we are good. You see, none has appeared. None has appeared from sorry. So I'm going to check my kernel, so don't worry. So let me just do dev dot is now dot sum. Let me see. No way and where it's present. Okay, it's just in residence. So what I will do is I'll just go up and either that the model is that the it could be that the stuff is changing because when we're generating it, we didn't clip it, but still on, we'll continue to change it. So let me just run it again and see what's going to happen. Okay, so we're gonna check the unique values. I think my probably did a line. So I'm just gonna go up. So we're just gonna patch it in somewhere. Let me just put it here again. And then we're gonna call that residence. But when you do it carefully, you're definitely not gonna see all of this. Let me just keep it here. So run all. All right. Okay, so we'll continue and I'm just gonna delete that. All right, so just like I was saying, right? So we need to change the reroute urban, that's to a number, and then the urban to a number, and then the same thing for the eyebrow nose. No should represent something. Primary should also represent something, and symbol, tertiary, and all of that. So that's actually basically what we are talking about right now. So first of all, let me just check df of residence dot value counts. Okay, not bad. So what we'll do now is, so it's the same thing that we did here, for mapping. So we could do something like df of residence. We'll say it's going to be this dot map, and then this is what we call encoding. So we'll say 1. For rural, let it be 1. For urban, let it be 0. All right. And then we'll also do the same thing here. We'll say df of eyebrow loss, just to be sure that was correct. It's going to be df of eyebrow loss dot map. And then we're going to pass a dictionary, and it's going to have no as 1 and yes as 0. So that's it. So the next one is going to be primary, secondary, and so we'll say dot map. So you pass a dictionary. You have primary as 1. Or we could start as 0. You have secondary at 1, and you have tertiary at 2. So the next one is going to be df of diagnosis. It's going to be df of diagnosis dot map dictionary positive 0, 1, negative 0. So we check out our df dot head. Check out df. Oh, what is that? Oh, so what we will do is so we're going to mark them as a string. All right, so maybe I'm just going to run this again. Let me restart this kernel and then run it again so that everything is going to be clearer. So just going to take some time for the kernel to start. So because we're running it on the Python environment. So that seems to be taking some time. So it's kind of running, and I'll just give it some time. Okay, okay. And I think it is just the diagnosis now that just to be sure, I hope I spelled that correctly. Okay, 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 okay. Just to know why it's map. This mountain has converted to now. Let's run everything again. Let's take out this. This is not supposed to be here. Because it has to map. Positive at so. Oh, this is the problem. We didn't spell it correctly. I spelled it wrongly here. Let's run it again. And negative as 0. Good, 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 good. All right, so now the next thing we're going to do now is, okay, so the next thing basically we're going to do is we've encoded. So we're now going to do some pre-processing. All right. So we must have everything as numbers. Okay. So I'm going to now pre-processing. Here we are now going to have our X and our Y. So we say our DF uh now if we cannot do df.info, you see that everything now is now an int. Is now a data type of numbers. All right, and that's the only thing neural networks as that's the only thing, even not just neural networks, generally does accept. So we're going to be training our model real quick, no wasting of time. If you want us to do some one or two visualization, we could just do that, maybe probably some some visualization. So we could say plot the plot, and then we'll say, well, let's plot skin patches against residence. So df of skin, and I'm going to say df of age against df of skin patches. So plot dot title, plot showing age against skin patches. And of course, we could, I'm just gonna let that run. Of course, we could have something like that, plot dot figure. or something like a fixed size of maybe 6 and 7 and plot dots. Choose plot dot show. So that's it. That's a very crazy plot. Let me just kind of reduce this to 4. 4. Plot dots ticks. You can take that argument. And I think what we could do here is we could do something like plot dot heat or look for kind of the better variables. We plot the lumps against temperature. Okay, so could plot the figure, say fixed size of 5 or 6. That's the plot dot show, right? Now plot the scatter, go plot scatter plot of df of lumps. What's it df dot lumps, df dot temperature. And of course, there are also other params you could pass inside of this. But I'm not really going to be talking so much about that. But just because of the peak value, so plot of title. Let's see. Sorry, I'm making a mistake here. I'm not even done. So I'm going to call it plot the title. I'm going to say lumps correlation. So I'm just going to say correlation between lumps and temperature. Plot dot x label and y label plot dot show. That's it. So you see, that's actually the correlation between them. The next one is we're going to look at preprocessing. So that's what we're going to say x string. So before we do that, we need to know our x. So also x is going to be df dot drop columns. It's going to be our diagnosis, okay? Of course, it's going to be our diagnosis. And then y is equals to df of, okay? So that's it. So we're good. So x string, y x test, y train, y test is equals to train test split x, y, then plus our test size of 5, 0.4 or 3, maybe something like that. And then we have our random state of 45. or whatever, and then we're going to stratify to 1. And then we're going to say, so that's actually our pre-processing, right? And let me just show you guys what I'm talking about. And then I'm just going to do something. Now, before I actually really go inside there, let's kind of save our clean data set. So I'm just going to say df equals to df2 CSV clean leprosy data. Just gonna join it now. Clean leprosy. Let's see what happens. So this is the clean data set, right? So this is the clean one. So peradventure we want to use it in the future. Yeah, so let's just have that in mind. So I'm just going to close this. So we just saved our data frame. So before we start, because what we're going to do now is I'm going to normalize it now. I'm going to normalize it now. All right, so I'm just going to do here. So that's it, right? So I'm going to do, so this part here is going to be scaling and normalization. So you're going to have scalar is going to be standard scalar. So you create an object of that particular blueprint. So I'm going to say X train is going to be scalar dot fit transform X train for Y train. X test is going to be scalar dot transform. So we're going to run that, and then we'll have scalar. So we've already scaled it now. So this is now converted to an array. And of course, we can now start doing our model prediction. So I'm not going to say scalar. No, I don't need to do that again. And of course, so if I show you X test, this is what it looks like. Okay. And again, if I kind of show you X train, now remember that Y train and Y test are still an array of zeros and one. Okay, so but then if it was on a neural network, we're going to do dot float or something, but that's not of that. So what I'm going to do next here now is I'm going to, since I have all of this in place, since I have all of this in place here now I'm going to now say, okay, model is going to be, that's my model right now. So it's going to be k nearest neighbors, k nearest neighbor classifier. Now it's going to take in a parameter of n neighbors as maybe 5, right? Now, what hyperparameter tuning? Hyperparameter tuning now is when we now start checking the params that are inside of this algorithm now to now know the one that is best fit for us. So if I do something like model dot best params or something, I think best param, I think it's something that's called get param, rather. Get. It's been long I did this. So model gets the params. So these are actually the params, right? So see here, default here is 5. If I change this to 8 and then run this, it's going to change to 8. But if I don't put anything inside here at all to train my model, let's see. So the default is usually 5. So let me just put n neighbors. It's going to be maybe 6. Let me use 6 neighbors. And then I can run this, right? And then I run this now, it changes to 6. So there's other hyperparameters here, the leaf size, the algorithms, and all of that, but I think there's also actually, I'm not really interested with that. So what I'm going to say is model. I'm going to do model.fit, and I'm going to pass in X-train, Y-train. So that's my model, right? And then if I cannot do Y-pred, it's going to be model.predict x-test. Okay, so this returns an array that cannot be used to copy. So if I want to check my accuracy, we could do something like the y-prober is going to be model.predict prober. We pass x-test. And then, but it has to be 1. So if we do model.predict, there's kind of, so here we're gonna do something like accuracy. It's going to be accuracy score y. You're gonna pass in your y. Now it kind of takes in some default parameters, right? So this is going to y-pred is going to be equals to y-pred, and then y-true is going to be equals to y-test. And that's it. So if I kind of print, I don't even need to print right now. So just to do the same thing for precision. Precision of model, and there's precision, and then something also going to apply for recall score. Model, I'm going to change this to recall score, and I'm going to do the next one as, maybe you could just call this F1 score of model. I'm just going to check out this. And so we could just do for classification, class report, call this classification. So is another one, so we could do for confusion matrix, confusion matrix. Model is going to be confusion matrix. I'm just going to pass in these params. Okay. Now, another way to understand is ROC score is going to be ROC EUC score as a param, but here it's going to take in Y test which is ypred and yproba. Again, so we'll run our, okay, yproba is not defined. Okay, so we'll run this cell and then we'll run it, everything works. So say print accuracy of model, and that's going to be accuracy, print the precision of the model. That's going to be precision, print that's going to be recurse score of the model, print so and then I'm gonna sorry, I'm gonna print and that's going to be arms. I think I didn't get that correct. So we run it, and yes, so that's how it works. So maybe I could just put a new line here. No, not here. Somewhere here. So everything sits pretty. And that's it. So these are actually the metrics. So I could just explain this is the accuracy. It means that the model performed poorly. It's what we've been juggling around with the data set and a lot. So we could just save the model, and precision is how many people have it. I already do have a full video on explaining precision for models and show all the evaluation metrics like accuracy. So you could just check out my video on that. But basically, this is what it means. Class report is for individual classes, accuracy, coefficients, metrics, and all of that. So what I'm going to do here now is the last thing I'm going to do is I'm just going to plot an RC AUC for this score. And what I'm going to do, I'm going to plot an RC AUC for this score. I'm going to plot the RC AUC. That's for fielding the true positives. More like want to know the distance. If a model predicts somebody to have, if a model predicts somebody to have a particular condition, what's the distance from being true to being false? That's truth, false. So don't mind what I just kind of wrote here, just for you to have clarity. So I'm going to use the RC code, which I did import. So I didn't really do some hyperparameter tuning because I just wanted to keep this video very simple. But if I do something like TPR, FPR, then underscore, or which could call this threshold, but I don't really need it, so I'm just going to say underscore. It's going to be equals to RC curve. And I'm going to pass in, it's going to take in two parameters here, which is going to be the Y prober and the Y test. Okay, so what I'm going to do now is I'm going to use the line plot the plot. Probably is a figure, and I'm going to say fixed size of maybe 5 and 5, and that's kind of a block figure. So plots, and then we have I think there's actually, it returns the false positive first before the true positive. FPR, TPR, because of, so it doesn't really confuse. So FPR, TPR, and because both of these are arrays, these are an array, and I think the comma should be there. That's the issue. And you're gonna have something like an F string. I'm just gonna use an F string to wrap an RC score, right? And of course, I'm just gonna have instead of this, I'm going to RCHC. I'm gonna pass a Y prober and have my Y test. And I'm just gonna pull this up a bit. So I have plot.x label, and this is going to be the false positive rate, and plot.y label. I don't need a nice spectrum. Y label is going to be the true positive rate. I think I could still have something here because this could just be two decimal places. And what I'm just going to do, I'm just going to wrap it to the round function. And two. And then we could have plot, just have a line plot 0, 1, 0, 1. Line style is going to be maybe dash, 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 tick, tick. And plot dot. This is just kind of the label. Of course, that's a label because it's going to come as a label there. Excuse me. Legend and plot dot show. The title is going to be ROC curve for the Leprosy Prediction Model. Plot.tight layout. Plot.show. So let's see what comes out. And what's the issue? Continuous format is not supported. What's that? And continuous format is not supported. I want to know why. Let's bring Y test front and put this back, and still says the same thing. Figure size axis. Okay, it said, we need to debug. Debugging is very important. So we'll have this FPR, TPR label is this. Ours is called round. I think this is supposed to be wrapped in a tuple. Ours is called round of this. Let's just kind of take this out for 1 second and see what happens. All right, so this is what we have, right? And this is just kind of what our plot looks like. So the lines, the yellow one is the original. So you see that our model performs very poorly, really very poor. So, but I need to put that back because that's the label. And round, take out the round function, closing parentheses. Oh, I think that's the issue. Continuous fault. Mm, okay, I think the figure is very small. Let me increase it a bit. And then we'll just put some round function there. And it's going to take in 2 or 1. Let's just make it 1. And is it consists of myself and mental? I just need to know why. Not pure label. Mm, this is. This is where the problem comes from. Why test has to come first. That's it. It must work now. And that, so let's reduce this a bit to 5, 4, and 5. All right, so that's it. So this is the legend, and it tells you that this is the blue line is for the RC. So guys, that's definitely going to be that. Not really much to debug. Let me just put an equal sign here so that, yes, I think that's fine now. RC, AUC score, whatever thing you might call it. But this is actually what you need to know. So let's kind of save our model. So I'm going to say here, I'm not going to make any prediction in this video. You could check out my previous video, prediction. So I'm going to, no, not prediction now. Okay, let's just make predictions. Well, since it's here now, that means I'm going to say saving and prediction. So I'm going to say to save our model, to save our model. So we're going to say joblib.dump, and then we'll call the model. What's the name of our model? Model. That's it. We didn't contain it on special thing. Say KNN model for leprosy prediction.pickle. So you must use this extension. So we're going to print model successfully saved. So if I can drag this, you see that this is the model. Okay. All right, so it can be displayed here, but we can still use it. So to make prediction now, also so say loaded model. So load model or whatever. It's going to be joblib.load, and then I'm passing the KNN model pickle. And then, of course, I'm going to print model loaded successfully. And then I'm going to now say to make prediction. So we're going to say, now I'm going to get my X train, my X test, right? Which I did use, okay? Or what I can do is from my x.log, I could just pick out. So I'm going to say sample patients is going to be x.log, and I'm just going to pick 9. Let's see what it gives me. Let me just kind of print sample patients. Okay, it just gives me 2 numbers, right? And I'm just going to add another number. What happens? It gives me 2. Let me just call this 4. And I'm just going to add another one. 3. And Try again. So it gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Now, I'm going to make predictions with this, but I'll still have to scale it. Okay, so these are how many patients now? We have 1, 2, 3, 4. I think they're all the same now. So this is just like the continuation. Sorry about that. So these are 4 patients, 4 random patients. And I'm just going to pick number 1 person. So this is the first person. Okay, so I want to use this one to make prediction on this model, right? So I just picked a random one. Let's locate 4, 2, 6, 46. So this is the number 46th person. Okay. And well, whoever, I'm going to say scaled. I'm just going to say sample patient. Let me make it 2, 3, right? So our sample patient is equals to scalar dot transform sample patients. Okay? So it's not an array. And then I'm not going to say no need to do that. So I'm just going to just use X as feature name, but scale that, who cares? So I'm going to say print. And I'm going to say prediction. Let me call it my prediction. My prediction is going to be load model dot predict. And of course, you could get the params of this and do hyperparameter thing, but not really so well, because hyperparameter thing is just to get, so I'm just going to pass that. It's just to get the best model. So my probability is going to be, because we still need that loaded model dot predict probable sample patients. Do you need to do something like this? Maybe. So could you print prediction for both is, so you're gonna print my prediction. I'm gonna print probability for both of them is my. So I'm gonna print that. So you see what it means here, that is 0. So that means the probability of this person not having this infection is 0.3. And this is also 0. Probability of not having it is 0.5. So that's actually going to be that, guys. The last thing I'm going to do here is to show you how version control works. Control backtick. I'm going to press git init git add dots all of the columns. I think this was not really fair because I should have matched in to save all of them. Looks like, well, I'm going to commit again, git add again, git commit, initial commit. So that's it. So I'm going to go online now, and I'm going to go to my Git repo, and so I'm just going to touch here. So I'm going to call this Git Leprosy. It's August 22 Leprosy Prediction. Created the Leprosy Prediction Model. Okay, so we'll go back to our code editor and we just stay there, copy this command to push. And that's it. And so if I go online now, so you see it's actually all my commits. So these are our data set, our clean data set. You can see it, everything is here, and that's it. So, and this is our KNN model. So it means that anybody can fetch this model and use it. So we could do some GitHub actions, push this model to production, and then people can use it to make predictions. So this is our full code. And then this is our practice code. This is our practice code. This is our unclean CV. Remember when we did our unclean leprosy prediction and all of that. So that's actually that for this video. If you found this video really very helpful, the git command definitely is going to be on this is going to be on the description. You could find it there. Everything is 100% Jupyter, no, of course, written in Python. So that's that. I'm going to make the full, you could check out my Git repository and you will get the full code, and you can download the data sheet there, you do whatever thing you want to do, you could fork it, because just come to my Git repository and you can fork the whole data sets and use it. That's what we call it. So this is it. This is what I mean by that, just so you understand. All right, so guys, other than that, thank you very much for your time. And yeah, so some of the practical videos, maybe engaging you guys, having people share slides, is definitely going to be on my next video. But that is just what you need to understand if you have actually followed me, particularly to this very point of this conversation that we've had this afternoon. So thank you for your time, and